Hello, welcome to Modern Data. In this session, we're going to talk about files and partitioning. So just a quick reminder, our examples are always modeled on the Azure cloud, on Azure Data Lake Storage 2, and using Azure Synapse Analytics. Because it's going to be talking about files, then we'll be concentrating on how files are compatible with these tools, and that would be deployed on Azure Data Lake 2. So on these environments, the main file types that you're going to see is Avro from Apache, which is a row-based file format, Parquet from Apache, which is a column-based file format, and Delta Lake, which is not really a file format at all. Actually, it's an implementation of ACID compliance and time travel history over the top of Parquet files. You'll also see CSV files, comma-separated values. They could be in just plain text files or in files delimited by the CSV extension. We use Excel files quite considerably. The Microsoft environment has drivers for Excel files, and you'll also see quite a bit of JSON and XML. We're going to focus on Parquet in particular, although I'm just going to do a quick rundown of Avro's, Parquets, and Delta Lake. So Avro from Apache is a data serialization system that's straight off of the Apache documents. It's a row-based file format. It's a mature format. It supports schema drift or evolution, different patterns actually, and its writing operations into Avro are far superior than other formats. It supports partitioning, so folder and attribute elimination, and the format must process all columns for each row. It's costly when only a few columns are needed compared to a columnar format file type. Only option that from the default capture for the Azure Event Hubs, so it's there is no other option. My guess is that's because of the write operation superiority of that file format, but also SQL on Demand doesn't recognize Avro files as a standard format. So if we look at the key at the top of the page here, we can see that SQL on Demand it's not compatible with, Synapse Spark Pools it is, and pipelines and data flows it is. So Parquet from Apache, the official line is Apache Parquet is a common storage format available to any project in the Hadoop ecosystem. For the purpose of Synapse Analytics and the Microsoft ecosystem, this is our most compatible file type, with compatible natively with SQL on Demand. We can access Parquet files through Spark Pools, and we can also access Parquet files through pipelines and data flows. So it's a columnar-based format which supports partition, folder, and attribute elimination. It supports schema drift and evolution, and reading operations in Parquet are far superior to other formats. So only a few, if only a few columns want to be loaded, this improves that performance even further. It's compatible with all the different Synapse compute methods. So let's have a look at Delta Lake. In reality, Delta Lake isn't really a separate file format. It's an open source project that enables a building of lakehouse architectures on top of existing storage systems such as ADLS2. Data Lake it's a framework and a library over the top of existing Parquet technology. Effectively, it's a manifest of Parquet files that create or work up to a logical object of data. It implements full transactional ACID compliance and time travel and history, with some limitations to be noted. I've put SQL on Demand compute compatibility as amber. The reason for this is that it's currently in public preview. It hasn't gone through to open availability yet within the environment. However, it is fully compatible at a particular version with Spark pools and with pipelines and data flows. Okay, moving on to file size and compression. This specifically for the cloud and really specifically for ADLS2 on Azure. But the ideal Parquet file size is somewhere between 100 megabytes and 1 gigabyte of compressed data. This is a very, very rough guide. The main issue to come from file sizes is SQL on Demand has a maximum number of files that an open row set command, and it's undocumented, but however, looks like it's around 10,000 files causes SQL on Demand to have issues. The Spark scheduler also has issues with many small files. So when I say many, we're talking in the tens of thousands or even potentially hundreds of thousands of small files, combining those into one logical object. So when considering file size, it's a balance between size and number of files and a design of a partition schema. Compression has the largest effect on read performance. So if you take nothing else from this presentation, that's probably the one key element to take away. So to maintain compatibility, we use Snappy Compression when writing data through Synapse, Notebooks and Spark, or through Pipeline and the integration runtime. The reason why it creates the largest effect on performance is it allows the compute to move much smaller blocks of data around without compromising the ability to read the data within. Typically this is about a 10-fold difference. So 100 gig file once compressed will be 1/10 of that size. So be about 10 gigs after compression. So let's have a look at partitioning. Partitioning provides an increased performance through partition folder elimination, and also it allows for the partial reload of data following corruption or an incident requiring a reload. Effectively what we do when we partition into folders is we are taking portions of a logical data object and splitting those into individual folders with files within. So a common partition scheme is by day. Many queries will limit the income or the data being included in a record set by a number of days. So in that scenario, it will be logical to actually separate the data into day folders. And in this example, Z part key, Z denotes that it's a metadata field, and part key is the partition key. It's used to name the metadata field for this partition. So if you see the example on the right here, we've got folders with this key pair syntax style. So we've got Z part key equals and then the date fields. These can be evaluated by the query engines from all three of the different computes on Azure to allow the query execution engine to eliminate folders where the Z part key does not match the values as needed for that particular query. If we look in one of those folders, so if you notice here in Beam Houston Destiny folder, if you look in one of these folders, the data is partitioned by day, the files are compressed using Snappy Compression, and both of the files within that folder sit with a reasonable file size. Okay, so that concludes my video about file types. In later videos we'll talk about how we use SQL on Demand or Spark notebooks and Spark pools, or Azure Data Factory pipelines and data flows to be able to create and manipulate these file types. Thank you for listening.